All right, hello everybody. Welcome to BYJU'S. I hope you guys have had an awesome day so far. My name is Adil. I'm going to be one of your math instructor here at the YouTube channel of BYJU'S. Okay, and today we are going to be doing a sprint session on the concepts that you have already covered before. So plenty of exciting problems are there lined up for you. But before we start off, just let me know if I'm visible and audible. Just quickly give me a thumbs up in the comments box and I shall understand that you are able to see me and hear me properly. Okay, so Rashmi says good evening. Good evening, Rashmi, Vimi Gupta. Okay. Okay, so Shivansh, hello. Pragati, good evening. Hi, good evening. All right, so I have some comments. Thumbs up, Kavya and Prasanna. So we are good to start here. Okay, cool. So first thing that we're going to do here is go through the topics that you have already covered before so that you have an idea as to what kind of problems you shall be expecting. Okay, Devansh says hi. Hello, Devansh. Himani, hello. Neha, hi Neha, Alok, hello. Come on, move on now. Cool, so these were the concepts, guys. We're going to be looking at questions from family of numbers. Then there's going to be questions revolving around fractions. Then you have rational numbers. I'm sure you are familiar with the definition of rational numbers. These are numbers that can be expressed in the form of a fraction, where of course the denominator can't be equal to 0. And then you've got irrational numbers. You know, these are numbers which cannot be expressed in the form of a fraction. Okay, now can you tell me the most popular irrational number that you have encountered so far? Come on, tell me an example of an irrational number. I'm sure you guys know this. Yes? Lakshmi says, a very good evening. Okay, good evening to all of you. Come on, an irrational number. Pi, right? I mean, come on, it's got to be by far the most popular irrational number in the world, right? How do you define pi? Pi is the ratio of circumference of the circle to the diameter. Okay, now I have some interesting facts related to pi. All right, here comes the first one. In 2019, there was Emma Haruka. She was an employee from Google Japan, and using Google's cloud computing services, she was able to calculate pi to 31 trillion digits. Let me just write that down here for you. 31 trillion digits. Okay, by the way, to just give you a perspective, 1 trillion is 1 lakh crore. Okay, so 31 trillion digits would be 31 lakh crore, and this task was accomplished using a supercomputer, as I said, Google's cloud computing services. And can you imagine how much time it took for this calculation to happen? Well, I have that written down here for myself. 170 terabytes of memory was required. Okay, 25 virtual machines were calculating this, and the task took, yes, 121 days. All right, so calculating pi, because pi is magnificent. It goes infinitely longer. As one of the comments says, Tejaswini, yes, this is non-terminating, which means it doesn't end, and it is non-recurring, which means you don't see any repeating pattern in pi. But then there's another thing here. In the year 2021, this record was broken. Yes, this time by researchers in Switzerland, and they were able to calculate pi till, if I'm correct, 62.8 trillion digits again. Okay, and this again was done using a supercomputer, of course, but this task was accomplished in just 108 days. So you see, calculation of pi is kind of like a, you could say stress test for a computer. So you can say, hey, look, supercomputer, if you can calculate pi to these many trillion digits, well, you can accomplish quite a few wonderful tasks like, let's say, modeling the universe or data crunching, which is heavily involved in numbers. Okay, so yes, I read some of your comments here. Yes, it is too long, 31 trillion digits, and the record has been broken, 62.8 trillion. As I said, 1 trillion is 1 lakh crore. So 62.8 trillion, you get the idea, right? So that's how magnificent pi is. I thought you guys should be knowing that. All right, cool. And the last topic that we're going to be looking at is decimal expansion. Okay, all right, now let's move on from this. After you know that wonderful piece of knowledge, of course, you guys know what to do, right? subscribe to the channel so that you're not missing out on the important updates and you're able to attend these live sessions on time, and if at all there are any changes, you'd be the first to know. So make sure you subscribe to this channel, and let's move on now. All right, so here's the first question coming your way. Now, I want you guys to be ready with some papers and a pen or a pencil, and please make sure that you're working through these problems along with me, because for some of the questions, I may give you an alternate way of solving a problem, and that's going to come pretty handy when you're taking some multiple choice tests, let's say. Okay, cool. So I have some comments. So Bhakti, yes. Shakil says unstoppable pi. I like that, my friend. All right. So need target. Okay. Hi sir, you teach nice. I'm glad you like that. Lakshmi says again, I know about it. Well done. It's nice to see some inquisitive mathematicians in the comments box here. Awesome. Awesome. So shall we begin now? All right. Are we ready? Yes, we are, right? Come on, I hope you guys are ready with some papers and pens, right? Come on, work through this along with me. Let's do it. Find 6 rational numbers between 3 and 4. Okay, now there is a method to do it as prescribed by the textbook, but then there seems to be a quite logical way to approach the problem as well. Like let's say 3 here and 4 here. All right, now what I'm going to do here is multiply and divide by 10. Okay, multiply this by 10 and divide this by 10. I'm going to do this to both the numbers. If I do that, the numbers don't change. They stay the same. So now it can be written like 30 by 10 and this thing can be written like 40 by 10. I can do that, right? Because 30 by 10 is nothing but 3 and 40 by 10 is also 4. Yeah, cool. So now keep the denominators the same and just keep increasing the numerators by 1 and you got it. Okay, so the next can be 31 by 10. Okay, then 32 by 10. Then you have 33 by 10. 34 by 10, 35 by 10. You get the idea, right? Come on, 36 by 10, 37 by 10, 38 by 10. So by now you've figured out more than 6 rational numbers quite simply. Yes, well done. I see some answers there. So good. There are many ways of doing it, and this was by far, a quick way of approaching it. But if we are to follow the method that is there in the textbook, let's say if the question asks you to do it in a particular way, then I'm sure you guys should also be knowing that method as well. Come on, let's go ahead and check that out now. Okay, so here the idea is we're going to be using the concept of midpoint. Okay, so let's say I ask you the middle point between 1 and 5. You know this, right? 1, 2, 3, 4. So what is the middle number between 1 and 5? 3 is the middle number, right? Another way of looking at it is, you add these two, the first one and the last one, and then you divide by 2. That's another way of getting the middle number. So this is the idea that you shall explore to figure out 6 rational numbers between 3 and 4. Awesome. Come on, let's try this method out now. Okay, so first thing that we do here is your 3 is here and your 4 is here. So I add these two and divide by 2. Okay, so awesome. So when you do that, what do you get? 3 plus 4 divided by 2 and you get 7 by 2. So that here is going to be your first rational number. And you repeat the process. That's all you do. Okay, so now, you take 7 by 2 and 3. Look, you're taking this 3 and you're taking this 7 by 2. And again, you repeat the same process. You add these two and then you divide by 2. So when you do that, you get the number which is in the middle of these two, 3 and 7 by 2, and that here is going to be 13 by 4, and the process repeats like that. You can go infinitely long. Okay, so next, again, we repeat the process, and now we've taken what? 7 by 2 and 4. So this time we've taken these two and then added them and divided the result by 2, and there you go. We've got how much? 15 by 4. And as I said, you are welcome to keep repeating. Okay, till you get to, of course, 6 rational numbers here. And then next, what have we done? We've taken these two, 3 and 13 by 4, added them, divided the result by 2, and then what did we get? 25 by 8. And as I said, in this method, it's a fairly simple one, but I'm sure you guys agree to this. The method we discussed in the beginning, where we multiplied and divided by 10, that has got to be the easiest method, right? Not that many calculations involved. Okay, so like this, we can keep proceeding, okay, adding and then dividing it by 2 to find the middle number of those two. Like here, what have we done? 15 by 4 and 4. So we've taken these two, added, divided by 2, and we got the middle number of those two. And then we repeated the process. Okay, you could have also taken this. Like, let's suppose you decide to take these two, then the answer would be what? 13 by 4 plus 7 by 2 divided by 2. So this is going to be 13 by 4 plus 14 by 4 divided by 2, and that would be 27 divided by 8. So this number right here would be 27 divided by 8. You're free to choose your own. It's just that you've got to know the process of doing these things. Okay, yes, this is a long method, but then as I said, the one we discussed initially, that was quite a short one, right? So cool guys, this is how you figure out 6 rational numbers between any 2 numbers given, because between any 2 rational numbers, there are going to be an infinite number of numbers. All right, awesome. Now, I'm sure you guys are good with this. Well done. Let's move on to the next question now. Okay, by the way, this is going to be the solution. These were the 6 numbers, and we got a different set of answers. Maybe in the first method we tried, but then, hey, look, both are correct ways of solving the problem. Awesome. Now, let's solve a similar kind of a question. Moving on to question number 2 now. Same problem, okay? Find 5 rational numbers. This time, the numbers have been given slightly different. 3 by 5 and 4 by 5. Okay, so what do we do now? Can we repeat the same process? Well, we can do that. First, let's multiply and divide by 10. Yeah, so 3 by 5. Let's multiply by 10 and divide by 10. So then in that case, the first number becomes 30 by 50, right? The first fraction. And if I do the same, apply the same idea to the second fraction there, 4 by 5, multiplying the numerator and denominator by 10, this is going to become what? 40 divided by 50. Now, keep the denominator the same and keep increasing the numerator by 1, and that's it. You are not just going to get 5, you're going to get how much? You're going to get 8 or 9, yeah? 31 by 50, and then you have 32 by 50, and then you have 33 by 50, 34 by 50, 35 by 50. I'm sure you get the idea. I don't need to go on and on. 36 by 50, 37 by 50, 38 by 50, 39 by 50, and that's it. Right? So Vedika already has the answer there. And who else? Yes, Srishti. Can we do it by equivalent fraction? Yes, you can. You can try that out as well. Okay. Okay. Others also have the answer. Vedika has the answer. All right. Now, shall we move on? I'm sure you guys have understood this method. Now let's try the method that has been prescribed in the textbook for you, and that is the method of taking averages, that is the midpoint. Okay, let's try that out using that method as well. So as you can see, I've got 3 by 5 here and 4 by 5 here. Now what would happen if I add these two and divide by 2? So 3 by 5 plus 4 by 5 divided by 2, after simplification, what you get is 7 by 10. And that's going to be the number in the middle here, right? This is the 7 by 10 that you've got. Repeat the same process. Like in the next step, what have we taken? We've taken these two here, 3 by 5 and 7 by 10. Add these two, divide by 2, and what you get is how much? 13 divided by 20, and there you go. You've got your second rational number. Okay, we're going to repeat the same process now. What have we done here? We can take these two. You can also take these two. You can take these two. You can take any combination you want. Add them, divide by 2, and the idea says you will get a number which is in the middle of those two numbers. Or I should also say it's kind of like the midpoint of those two. Cool, guys. And when you repeat this, well, these are going to be all your answers, and these are the 5 rational numbers. Methods may differ, but then answers are possible, because as I said, between two any rational numbers, they are going to be an infinite possible rational numbers. Awesome. Now let's read some of your comments here. Okay, all right. Okay, I'm glad that you like that. Awesome. Cool. So let's move on to the third question now. Show how root 5 can be expressed on a number line. Okay, so first thing, root 5 lies between root 4 and root 9. Why am I taking root 4 and root 9? Because I know they are perfect squares, right? Root 4 I know is 2, root 9 is 3. So root 5 lies between 2 and 3 on the number line. Like let's say they asked you root 11, then what would you do? If they ask you root 11, then you know this is going to lie between root 9 and root 16, because root 9 is 3 and root 16 is 4. So root 11 is going to lie between 3 and 4. So this is how you make up this estimate. Okay, so this we know it. Now we want to locate this on the number line. Okay, so how shall we do it? Well, we're going to call Mr. Pythag. Who is this Pythag? Well, he's the guy who gave you your famous Pythagoras Theorem. I'm sure you guys can recollect the Pythagoras Theorem, right? So what does the Pythagoras Theorem tell you? If this is a right angle triangle and this angle is 90 degrees, then if I call these sides A, B and C, what happens? The square of the hypotenuse is going to be equal to the square of the other two sides. So I'm trying to make this as root 5, let's say. then what shall I take A and B to be? Well, I can take A to be 1 and B to be 2. Will that make the hypotenuse root 5? Yes, it will, right? 1 square plus 2 square under root, that's going to make it root 5. So this is the idea that we are building upon. Okay, so look, what have we taken? We've taken a line segment of 2 units on a number line. Okay, so far we are clear in the approach, right? Not that challenging. I'm sure you guys are following me through. Cool. So first thing is draw a line segment 2 units on a number line. We can do that. I'm sure you guys have done it as well. And next thing that you're going to do is draw a perpendicular of 1 unit from B, because you remember thinking in terms of Pythagoras theorem. So this right here is 2 and this is 1. And you know what happens when I join these two? What would happen when I join those two? Well, that would form the hypotenuse of that right angle triangle that we just created, the tiny right angle triangle that we created. And that's going to be how much? That's going to be root 5, right? So this line here, as you have seen, this is going to give you root 5. Right? Now all you need to do is take a compass, be careful with that pointy edge, keep it over here at 0 and then draw an arc, okay, by measuring AC. Alright, so when you do that, well, it's going to lie at anywhere between 2 and 3, probably a little bit closer to 2, and that's going to be where root 5 is. Amazing, isn't it? Root 5 is an irrational number, which means it is non-terminating and non-recurring. And the beauty is, still you are able to locate it on the number line. Yes, right? Awesome. Cool. Okay, very fast. Oh, all right, I'm going to try to go slow. That was quite helpful for me. Okay, I'm going to try to go a little slow here. So I'm sure you guys have understood this, right? So what have we done? First thing that we did here was, we took a line which is 2 units long, okay? Let's say, let's call this point 0 and let's just say this is, okay, let's just call this A and let's just call this B. Then what we did was, from B, we drew a perpendicular with 1 unit, okay? That unit can be anything. Let's say you decide this to be centimeters. This can be in centimeters as well. Unit doesn't matter as long as both are tallying in terms, okay? And then when you join the hypotenuse, as per the Pythagoras theorem, you get root 5. As simple as that. And then when you keep the pointy edge of the compass on A, measure this line and draw an arc, it's going to fall between, as I said, 2 and 3, and that's how you get your root 5. Okay? Very good. I'm sure you guys have understood. So this is how you can plot. Method is this. Okay? This is how you plot, irrational numbers on a number line. Let me see if you have understood this or not. How are you going to plot root 13 now? Root 13, how will you plot it? In case the question asked you root 13, then what would you do? 3, 2, right? Because 3 square plus 2 square, how much is this? 9 plus 4, and then this is going to become 13 as per the Pythagoras theorem. Okay, so in order to do problems like this, you use Pythagoras theorem. Anchal says, good evening, sir. Good evening, Anchal. Utkarsh, yes. Archit, got it. Awesome, Archit. Ria, please explain it one more time. Okay, Ria, I'm going to try this one more time. The process is pretty simple, Ria. As long as you know what Pythagoras theorem is, you should be able to crack this through. So what have we done here is we've taken this distance to be 2 units. You can do that on any number line, right? Like let's do this, okay? Draw a line 2 centimeters long using a scale. I'm sure you can do that. And from this point, construct a perpendicular. You can use a protractor if you want to. Mark an angle of 90 degrees and draw a length 1 centimeter, okay? And then join these 2 points. And that's it. This is root 5. Cool. So now keep the pointy edge of the compass at this point, measure this length here, and then draw an arc. And that's it. You are going to get your root 5. Okay? Very good. Very good. Well done. Okay, so I believe we are ready to move on to the next question, because trust me, there are plenty of shortcuts coming your way for some kind of questions. Okay, now this is the problem involving decimal form. So write the following in decimal form and say what kind of decimal expansion each has. Now, I'm sure you are familiar that 2 types, right? One is terminating. One you have is terminating decimal, which means it ends, it terminates. And then you have non-terminating. But then non-terminating decimals are of 2 types, right? First type is there can be a recurring pattern, and the second is there will not be any recurring pattern. right? And what do we call non-terminating, non-recurring? You gave the answer initially. Those are irrational numbers. And then terminating and recurring, or simply terminating, we call them rational numbers. Okay, so these are the two types. So 36 by 100, we are going to simply divide. We're not doing anything here. We're simply going to divide. And when we divide 36 by 100 using this division, what we get is 0.36. I'm sure you guys can do the division pretty well. So when you divide 36 by 100 using this method of long division, you're going to get 36. And what do you observe here? What is happening here? Well done. It is terminating. Archit says 0.36. Rashmi says terminating. It's terminating and non-recurring. Well done. Okay, so you guys have understood. This must have been a pretty good question. So that's why this is going to be a terminating decimal. Amazing. And this is going to be a rational number as well, because, hey, look, it is in the question itself. You've expressed this in the form of a fraction. Awesome. Let's move on to the next problem now. Okay, so this time the question is the same. The number has changed. This time you've been given 1 divided by 11. So you've got to repeat the same process pretty much. What you will do here is divide again. Okay, so let's say you're trying to divide 1 by 11. How would you do this? Well, when you try to divide it initially, it won't go in the 11 times table, right? So you put a 0 here and then you put a decimal point, okay? And then you add a 0 to this, right? 10. 10 again doesn't go in the 11 times table, so you add one more 0. So far it is 0.0, and now you get 100. Now 100 goes in the 11 times table, right? 11 times what? You get a number closer to 100. 11 times 9. So 11 times 9, 99, and when you subtract, the remainder is 1. Again, I'm going to add 2 zeros. Okay, sorry, 1 0. 10 again doesn't go in the 11 times table, so I put a 0 here, and then the process repeats. So what you get is 0.90909090, and then the process goes on and on and on, right? Very good. The process repeats. Bhakti, okay? It's not going to end at 0.09. The process is going to repeat. It is non-terminating. I'm sure you understand that. Muskan as well. This is non-terminating. Very good. So this is going to go on and on and on. Okay? Now, we know it is non-terminating for sure. But now what we've got to understand is that, is there a pattern to this? I'm sure you guys have decoded the pattern, right? This is going to be what? 0.09090909. So you see, this pattern of 090909 keeps on repeating. So how do you write this in bar notation? We write it like 0.09 and then we put a bar on top of it. Okay, so this is going to be represented like this. So yes, this is non-terminating for sure, but there is a recurring pattern that repeats, of course. So that's the reason why this is going to be a non-terminating and repeating decimal. Well done. Well done. I liked some of the answers. You know, Pushpa says it is a rational number. Well done. This is going to be a rational number because yes, this can be expressed in the form of a fraction. Well done. I'm sure you guys have understood these. Let's move on now to another question. Okay, cool. Let's move on to another question now. Okay, so we've been given 1 by 7 here. Okay, so again, what does this tell us? 0.142857, quite a lengthy number. So you have a bar on top of it. Let me decode that out for you. So 1 by 7 is going to be this, 0.142857, 142857, 142857. So this is how this pattern is going to go on and on and on and on. Okay, so that's the reason why we don't want to be writing all of that. We simply say this 0.142857 and we put bar on top of these digits to signify they are repeating. I'm sure you guys are familiar with that. Very good. Now we want to know, based upon the value of 1 by 7 given to us, can we figure out 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7, thank God, without actually doing the long division? How can we do this? Well, there is a method to that, and that's a fairly simple one. All you do, how do you write 2 by 7, guys? 2 by 7 can be written like 2 multiplied with 1 by 7, right? I can do that. Yes, I can do that. So when you do that, all you need to do here is multiply this by 2. That's it. And when you multiply that by 2, this is what you get. Right? Shall I show you that multiplication? Okay, let me just do it for 2 by 7 and I'm sure you would understand the process for 3 by 7, 4 by 7, on and on. So 0.142857. When you multiply this by 2, what happens? 14. Okay, one remainder, 2 times 5, 10, 11. 1 remainder 16, 17, 1 remainder 2 times 2, 4, 5, 2 times 4, 8. So look, when you're multiplying, this is the pattern that you get 2, 8, 5, 7, 1, 4, and then you repeat the same thing. So when you multiply 3 with 1 by 7, what do you get? 3 by 7. Very nice. When you multiply 4 with 1 by 7, you get 4 by 7. When you multiply 5 with 1 by 7, 5 by 7. As simple as that. So this is how, without actually performing long division, you are going to get, these values. Now hang on. I have something interesting for you, and there is going to be a question based on that as well. What happens if I multiply 7 with 1 by 7? What would be the answer if I multiply 7 with 1 by 7? Because I'm sure you guys can do these multiplications. They're not that challenging. All you've got to do is multiply this number here with 2, 3, 4, 5, and 6. 7 multiplied with 1 by 7. What is it going to be? 7 multiplied with 1 by 7, we know this. This boils down to 7 by 7, which is 1. Okay, but when you do this multiplication here, you are going to get 0.999999, and there is a way to prove that this is equal to 1, and there'll be one question that we would be solving for this. Okay, amazing. Have we understood this? I'm sure we have. Got it, says Lakshmi. Well done. Yes. Prasansa Singh says 7 will get cancelled. Yes, my dear, it will get cancelled, and you're going to get 7 by 7, that is 1. Very good. 1 is the correct answer. Cool. So we are through. I'm sure you guys are following me. I hope I'm going at a reasonable pace at which you understand these problems. Come on, let's move on to the next question now. Okay. Now this is, listen to me carefully. There is a shorter way to calculate the answer for these kind of questions. But what we would be doing now is understanding the logic of the method, and I promise you, by the end of this, you will be able to calculate answers for questions like these, where you are given a non-terminating recurring decimal to fraction. You shall be able to do it in 20 seconds, I'm sure. Okay, cool. So let's understand the logic for it. First thing, 0.6 bar is, of course, what is this? Non-terminating. How do we know that? Well, there's a bar on top of 6. So what does this tell us? 0.6666 goes on and on and on. So this is non-terminating, but this is recurring. So this is by definition a rational number, which means we can convert it into a fraction. Can we do that? Yes, we can. Let's see how that process is done. Okay, so first thing, 0.6 bar, we write it like this. Okay, and then we're going to assume that, let's just say, call it x, or call it whatever you wish to. Let's call it x. Now, when you multiply this by 10, I'm sure you get this idea that the 6 comes here, and that becomes 6.66666. Okay, so this part is fairly simple. So all we have done so far is multiplied the number by 10. And now 6.66666 can be written like this. 6 plus 0.666, I can do that. Very good. But this value, if you remember earlier, we had assumed it to be x. Sorry, that was here. I pointed in the wrong direction. That was here. So in the place of that number, I can put x. See how simple this has become now. So now what we're dealing with is 10x is equal to 6 plus x. You guys know how to solve the equation. Plus x goes to the left hand side, plus becomes minus, and what you're left with, 9x is equal to 6, so x becomes 6 by 9. Cancelling off the common factor, that becomes 2 by 3. So this is the method of solving it. And as I said, good, you have the answers here. Pushpa 2 by 3, Lakshmi, Anchal Verma again 2 by 3. Well done, guys. Well done. Okay, now let's slowly increase the level of difficulty now. Okay, I'm sure you have grabbed this idea. This time, okay, notice that the bar here is only on top of 7. It is not there on 4. Okay, I'm sure you have noticed this problem. So if I were to convert it into a decimal and show you, this would be 0.4. Only the 7 is repeating, okay, because the bar is only on top of the digit 7. Okay, same concept, numbers have changed. That's it. Let's see how we can convert it. Since the bar is only on top of one digit, we multiply by 10. If the bar was on top of 2 digits, what would we do? What do we do if it was this 0.79 bar, let's say? Then since the bar is on top of 2 digits, immediately after decimal, we would multiply by 100. Okay, but as I said, there is a shortcut. You will not have to bother about all of this later on. Cool. So we've gone with the same process. Okay, we've gone with the same process. We've taken x to be this decimal which is given to us. Okay, We've multiplied it by 10 like we did in the last problem, and we get this 4.7777. Okay, now again, if I write this as 4.3 plus 0.477, you already know that I've taken 0.477 to be x. I've done that. So in the place of that, I'm going to substitute x, and this becomes a simple equation. 10x is equal to 4.3 plus x. Throw the plus x to this side. You get 9x is equal to 4.3. X is equal to 4.3 divided by 9, which can be written like 43 divided by 90 when you multiply both numerator and denominator by 10. Okay, so this here is the method. Okay, you've got one more problem coming your way, and then after that, I'm going to show you the shortcut as I promised. Okay, this is understood? Very good. All right, answer is 43 by 90 as said by Rashmi, Shivansh, Alok, Yadav says hi, hi Alok, Zarina Banu, 63 divided by 100. Okay, this is not going to be 63 divided by 100, Zarina. I'm sure you understand why. Right? There may have been a calculation mistake from your side. Okay, Archit says explain again. Okay, I'm going to explain this to you again. Okay, first thing is 0.47. Bar is on top of what? Bar is on top of 7, right? So that's the digit which is going to be repeating. I'm sure you guys follow that through. So this number here is going to be 0.477777, and this is going to go on and on and on, right? Very good. Now what I'm doing here is multiplying this by 10. Okay, let's just say this is x. Okay, when I multiply this by 10, I get 10x is equal to 4.77777. Okay, now I want to write this 4.777 as some addition thing where I have this 4777. Okay, and that's how I write this number here as 4.3 plus 0.4777 because I want to make use of this. Okay, once you've written that, this is the trick. Okay, once you've got this step correct, that's it, you've solved the problem. Okay, cool. Manjot Singh, as I've studied from him, he is the best teacher. All right, non-terminating. Thank you, Manjot. Okay, shall we move on now? I hope Zarina has understood this. Okay, cool. This was the problem that we were waiting for, weren't we? Express this in the form of P by Q, and I promise you, you will be surprised by the answer. Okay, so discuss why the answer makes sense. We are going to discuss this. Of course, the method is the same. Multiply this by 10, repeat the same process that you have. Okay, take this, multiply this by 10, this is what you get. What you're getting is 1. As I said, I told you this in the case of that irrational number problem as well, where 1 by 7 was given as 0.14 something, right, on top of that, and we multiplied 7 with 1 by 7, and what we got was 0.99999. It goes on and on and on. Therefore, even mathematics says that it can be approximated to 1. All right, so the method is the same. Very good. Now comes the interesting part. Please focus. Okay, I am going to repeat this again. Please focus, because this here is going to be the shortcut. Are we focusing here? Are we concentrating? I'm sure you guys are, right? So, shall we proceed? Because I would be needing your best concentration if you were to understand this, because once you understand it, nothing like it. Okay, cool. Now, we're going to write the answer in one step. That's it. Now, first step. Tell me how many, now we are looking at this question here, okay, this is a number, you have to convert it into a fraction. How many digits have a bar on top of them? Come on, tell me, how many digits have a bar on top of them? How many digits have that? These 2 digits, right? 2 digits have a bar on top of them, right? So first thing is we would be calculating the denominator. Now since 2 digits have a bar on top of it, I am going to write 2 9s. If 3 digits had a bar, like in this case, let's solve this one together as well. If 3 digits had a bar on top of it, in the denominator, I will be writing 3 9s. If 1 digit had a bar on top of it, I will be writing 1 9. If 5 digits had a bar on top of them, I would be writing 5 9s. That part is clear, I am sure. Very good. Now, after the decimal point, how many digits do not have a bar? How many digits do not have a bar after the decimal? It's this 3 and this 2. 2 digits do not have a bar. So I'm going to write 2 zeros. This step is simple, clear. So the number of digits that have a bar on top of them, you write that many number of 9s. And the number of digits that do not have a bar on top of them, you write those many zeros. Okay, so look at this number now. How many digits after the decimal do not have a bar? There is just one, right? What is that? 7. So that's the reason why I write 1 0. So you've cracked the denominator. Now let's look at the numerator. The numerator is again very simple. Take this complete number, remove the decimal point. Okay, remove the decimal point. What is this going to look like? 13258. If I don't consider the decimal point. From this, subtract the digits that do not have a bar. Okay, so 132. There you go. This is your answer. One step. You don't have to repeat that process to get the answer. You can get the answer directly. All right. Now, what is going to be the numerator here? We've already found the denominator, right? So take the complete number without the decimal. Okay, of course. All right. I need some space here. So this is going to be 27534. I've taken the number as it is without the decimal. And from this, I'm going to subtract the digits which do not have a bar. So that's going to be 2 and 7. So that's it, minus 27. And that's it. You get the answer faster. So this was the shortcut way of figuring it out. If we do 2 more questions, I'm sure you guys will understand this. All right. So come on, let's pick up 2 more problems and then we shall be easily able to crack this open. Okay. So how do we write it? Come on, you guys tell me now. What is the process? After the decimal point, how many digits have a bar? Look at this number here. Tell me how many digits have a bar? 2 digits have a bar, right? What are the digits? 5 and 8. So what am I going to do? I'm going to put 2 9s. Very good. How many digits don't have a bar after the decimal? There's only one digit without a bar. What is that? 3. So I'm going to put 1 0. That's it. Denominator is clear. And now what do we do to the numerator? Very simple, right? Take this complete number without the decimal point, of course. So 0358. Now 0358 simply means 358, right? So this simply means 358. Subtract 3 from it. 03. That's it. We are clear? From the complete number, I didn't write 0358 because since the 1000 digit is 0, it doesn't matter. We can write it like 358 because even if you write 03, it simply means 3, right? Cool. So this is the reason why. You have the answer pretty fast. Yes? So this is going to be 358 minus 3 divided by 990. Come on, help me out with this D bit now. Help me out with the D bit. First tell me the denominator. How many digits have a bar on top of them? After the decimal. After the decimal. How many digits have a bar? 2 digits have a bar. Okay, so they are going to be 2 9s. After the decimal, how many digits don't have a bar? Just one digit doesn't have a bar on top of it. So 1 0. We figured out the denominator. Now comes the numerator. Take the complete number without the decimal point. So I'm going to write 5 1 2 4. From this, I'm going to subtract the number which doesn't have a bar. So it's going to be this number here, 5.1. I will not write 5.1. Numerator is without decimal point. So this is going to be 51. This was the shorter way of figuring out the answer to these non-terminating recurring decimal. How do you convert it into a fraction? Okay, I'm sure once you practice this method, okay, you shall be easily able to work this through. Awesome. Shall we move on to the next problem now? I think we should be, right? Cool. So find 3 different irrational numbers between these 2 rational numbers. So far, in the first 2 questions, if you remember, we found out rational numbers between 2 rational numbers. Now we're going to find irrational. Now this is easier than rational actually because you can pretty much do anything you want to here. 5 divided by 7. First thing that you need to do here is convert it into a decimal. So you have to do that by division. Okay, so 5 you have to divide it by 7. So 0 point, okay, so this becomes 50. 7 times 7, 49, and then 7 times 1. Like that, you have to go on and you get this. Okay, 5 by 7 when you do the division. In a similar way, you've got to divide 9 by 11 and you will get this. I'm leaving the division calculations up to you because I'm sure you guys can figure the division out. Okay, so first step is to convert these 2 into decimals, and this is how you do this using the method of long division. Next step is, observe this, 0.714285, this is 0.81. Pick any pattern you want. Okay, it can be this. Just make sure you put ... in the end and people will understand that this is not terminating and there is no recurring pattern. Like I can have something like 0.7293, any random number will do, 0, 1, 5, 2, 5, 6, dot, 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 dot. This is enough to say that, hey, look, this is not terminating, and the numbers that you've selected here should tell the story that, hey, there is no recurring pattern here. That's about it. Okay, so this is going to be fairly simple. It's not going to be just these three. You can select anything as long as it is between these two. Another example that I can give you is something like 0. This is 7, 1 here, right? So I can take 7, 5 something. So 7, 5, 3, 1, 2, 0, 7, 2, 3, anything, as long as there is no recurring pattern. That's about it. Okay, so as you said, as I told you, irrational number figuring out was an easier task than when compared to, because we could make up our own irrational numbers here. But please make sure you put the dot, 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 dot. Otherwise, they may get an idea that, hey, look, this is terminating. Okay, awesome, cool. So I'm sure you have understood this one as well. Now comes homework time. Okay, so because, yeah, this is true. Practice is indeed the only way to get better at math. I must tell you that. And here's your homework problem. I'm sure this is a simple one, and I know all of you can crack this up. Okay, Pushpa has given examples here. Well done, well done. Lakshmi says, very confused in rational and irrational. There's nothing to be confused, Lakshmi. Rational is simply any number that can be expressed in the form of a fraction. Okay, whereas irrational is going to be a number that you can't write in the form of a fraction. So if we use that decimal terminology, rational is going to be something which terminates, something like 0.52, or something that doesn't terminate but then has a recurring pattern. So these two are going to be rational because you've seen it. You can convert it into a fraction. Irrational, on the other hand, no terminating and no recurring pattern. Okay, so that's all it is. Okay, so I'm sure you guys will crack this homework problem open. Please do not, say the answers now. Let others also get a chance to solve it. You can type the answers in the comment section below and let us know. And as you guys know, we've got you covered. All the amazing videos and content that we make are exclusively for you. And this is going to be your next concept session based on number system on the 3rd of May, 5 p.m., the same slot. And if you want access to free trial classes, you can find the link in the description box. Make sure you utilize that because, hey, look, these are free trial classes. You've got nothing to lose. Try out this method. All right. And of course, in the end, please show us some love. Okay. Like the video, share it among your friends. They may also find it pretty helpful, and subscribe to the channel and do not miss out any important updates. So that's it from my side, guys. I just hope that this session was helpful and you've learned something from the session. But my word of advice to you is always going to be this. If you want to get better at math, make sure you're solving as many problems as you can because that way you'll be able to establish those connections between concepts and questions. Okay, so I'm sure you guys will implement these strategies. So we're gonna meet next week, hopefully. So till the next time we meet, please make sure you take care of yourself, keep practicing and keep getting better and better. Thank you for your time and bye-bye.